Hello students, I am going to discuss a very important natural phenomena known as gravitation. We have learnt about motion and force. We also know that force is required to change the speed of a motion or to change the direction of a moving object. So force is necessary for these two things to happen. We also know that if something is falling down, it may be the leaves from the tree, the fruits from the tree, a ball in my hand, or some stone on the roof of the house top. If something is falling down, it comes towards the earth. Everything from top comes to the bottom. So a question arises, why it's so? There are other questions also, like we know, suppose this is the sun. Sun attracts earth towards itself. Earth attracts moon towards itself. So these are some natural phenomena we see in our day-to-day life. We also see that around the sun, planets, they orbit. Around the earth, this moon orbits or revolve around the earth. We are standing on the earth without toppling down, without floating in the atmosphere. So these all questions, they need some answers, some explanation, and this explanation is given by a force. An invisible force is there in between earth and moon, between sun and earth, between me and the floor beneath me, and all these things. So this invisible force, it is known as gravitational force. A very important force, gravitational force. All the questions I have just talked about, they can be answered, they can be explained on the basis of this gravitational force. We will just see how. The whole story of gravitational force began in 17th century when an apple fell on Sir Isaac Newton when he was sitting under an apple tree. All of us know this story. So immediately Sir Isaac Newton, who was a very influential scientist, started to think, when an apple can come, this is the apple, when it can come to earth, why this earth cannot go to the apple? So this is the question that arose in his mind. A very genuine, a very valid question, and there should be some answer to this question. Again, the answer of this question is also hidden in this force, which is now we know as gravitational force. How? According to the third law of Newton, law of motion, third law of motion of Newton, if this apple is exerting some force on earth, earth is also exerting the same force on this apple, because according to third law, every action has a reaction, and the force exerted by two objects, that is equal in magnitude but opposite in direction. So if earth is pulling apple towards it, this apple should also pull the earth towards itself. But we also know the second law of motion of Newton. What that law says? The second law says that F is equal to ma. F is force, m is mass, and a is acceleration. Or we can say A is equal to F upon A. Here you can see A and M, acceleration and mass, they are inversely proportional to each other. More the mass, less the acceleration, less the mass, more the acceleration. So in this case, in the first case, when apple is coming down to earth, the acceleration of apple is much more because its mass is very less, few grams, 10 grams or 20 grams or 50 grams at the most. So the mass of the apple is very less, so its acceleration is very high and it comes to earth. Now look at the second scenario. We are saying why earth is not moving towards apple, because again the same principle, the mass of earth is enormous, very high. Do you know what is the mass of earth? Mass of earth is something 6 into 10 raised to power 24 kilograms. This much is the mass of earth. That is, after 6 we have to put 24 zeros. So much kilogram is the mass of earth. So if we put this mass here in the second scenario, what will be the acceleration? Acceleration will be very, very less, negligible. So if so much mass is here, there will be no acceleration. Acceleration means earth cannot move towards apple. That's why it is explained on this second law of motion. And on these principle, all other things can be explained. Why moon is not coming to earth, not colliding with the earth, why earth is not colliding with the sun, because they are under this gravitational force which cause them to move around in a certain orbit. So this is how we can explain these things on these gravitational force. Later, Newton, he formulated that not only this apple or earth or moon or earth or moon or sun or planets or moon, they are attracting each other. Each and every object in this universe, they are attracting each other. This is the law of Newton, which he called as universal law of gravitation. What is the name of the law? Name of the law is universal law of gravitation. And he formulated this law, and the important thing about the law is that each object in this universe attract the other one, attract the other object. There is a force of attraction in between two objects in this universe. These objects may be terrestrial on the earth, or they may be planetary outside the earth, like the planets, like the stars and all other special objects. So now we will discuss what is this universal law of gravitation of Newton. So first of all, for the explanation of this law, one thing is clear to all of you, that is any two objects. Suppose the first point is the two objects should be there. Any two objects, suppose this is one object, object A, and this is the other object, object B. They are placed at a certain distance from each other. What we are saying, that A is attracting B and B is attracting A, and in between them the force is gravitational force. So what is the next? If these two objects A and B, they are placed at some distance, and this distance is taken from their centers, and this is denoted by D. In a straight line, both the centers are there and the distance is denoted by D. Suppose the mass of A is m1 and mass of B object is m2. So what Newton did, he formulated, and this is putting some force and it is also putting some force, and suppose the force is F. What he formulated, that force in between these two, the gravitational force F, is directly proportional to the product of their masses. You can write m1 into m2 also, that is the product of their masses. It is directly proportional. What does it mean? More the mass, more the force. If we double the mass, then the force will be doubled. If we triple the mass, then the force will be tripled. So F is directly proportional to the product of their masses. This is one thing. Now second, what he said, that force in between these two is inversely proportional to the square of the distance between them. The distance between them is D and the square of distance is D square. If it is inversely proportional, that is F is proportional to 1 by D square. These two things Newton formulated. So can you see what is here? Suppose the distance is 1 meter, then the force will be, suppose previously the distance is 1 meter, then the force will be, suppose I am writing equal, it will be 1. Suppose it is increased to 2 meters, then what will be the force? Now the force will be 1 by 4 of this force, because it is in square. 2 2s are 4. Here 1 1s are 1. So the force is 1/4 of the previous force. As this is decreased, the force decreased 4 times. So this is how the inversely proportion means, and if the mass is increased, then the force increased accordingly. Suppose this is equation 1, this is equation 2. When we sum up both the equations, F will be proportional to m1 m2 upon D square. Simple. Now if we want to change this sign of proportionality to sign of equality, if we convert this proportional sound to equality sound, we have to introduce a constant, and here the constant introduced is capital G, and it is known as gravitational constant. We will also learn a constant, other physical quantity, small g, that is different from this capital G. This capital G is gravitational constant, which we put when we want to convert this sign of proportionality to the sign of equality. This G is the constant of proportionality. So now F will be equal to G m1 m2 upon D square. So this formula we have, where the gravitational force F is equal to so much and its unit is Newton or N. So this is one formula you have to memorize, because we will do certain numericals based on this formula. F is equal to G m1 m2 upon D square. Now we will also do some numericals where we have to find out the value of this G. So we can very well form a formula where G can be calculated by cross multiplication. Here we have F d square is equal to G m1 m2, or G is equal to F d square m1 m2. So in this way we can know the value of G, which is gravitational constant. Why it is known as universal gravitational constant? Because the value of G is constant throughout the universe, on Earth as well as on other planets or moon also. That's why it is known as gravitational constant, universal gravitational constant. Its value does not change. Now with this formula, can we find the unit for G? What is the unit of G? We can very easily find. F is Newton, F is force, Newton, D is distance, so meter square, D square, so meter square, upon M is mass, mass in kilo, kilogram into kilogram, that is kilogram square. So formula we can write Nm square per kg square, or we can write Nm square per kg square. So this is the unit of gravitational constant. You memorize this unit also, and we will do some numericals to calculate force also and to calculate capital G also. Now, what is the value of G? What is the accepted value of this G? One scientist, Henry Cavendish was the scientist who first of all gave us the value of this G, and it is 6.67 into 10 raised to power minus 11 Nm square per kg square. Can you see the value is so little, so less the value is 6.67 into 10 raised to power minus 11. That is, we have to write 10, 3, 4, 5, 6, 7, 8, 9, 10 zeros before writing 667. So little is the value of this capital G. That's why the force in between these two objects, the force is G into, we are multiplying this value to m1 m2 by d square. So when this force is multiplied by capital G, who has a very small value, the force between two objects is very less. That's why if this is a pen, this pen is attracting me and I am attracting the pen. So both of us should collide with each other due to the force of attraction, due to the force of gravitational pull or gravitational force. But pen is here, I am here. We are not colliding with each other. Why? Because the force, the gravitational force in between us is very small, negligible. Why it is negligible? Because this is the force between me and the pen. And if it is multiplied by G, which is so small, so the total force will be very small or negligible. That's why the objects on this earth, they are not colliding with each other due to the very less force of gravitation between them. So this is about F and this is about capital G.